Hi folks, so the question we actually have in front of us here today, guys, is a development question from the World of Graphics textbook. It's on page 252. I've just taken a screen grab of it here. And the question itself says, example, a magazine holder, truncated prism, is shown below. Draw an elevation in the direction of arrow A, so we can see arrow A down here is looking at this kind of purple face here. A plan projected from the elevation in the direction of arrow B, so a plan looking down on top of it. And then an end elevation projected from in the direction of arrow C. So we'll see this kind of blue rectangular face here at the front, and obviously we'll see that surface there. And then we have to do a complete surface development of the magazine holder. Now these questions, guys, are important because they're actually based off truncated prisms. And essentially what that means is, if you imagine, as we know, it is a magazine holder, so obviously magazines will slot in and out of it and you can easily access them by taking them out. But it's a truncated, therefore that means basically that it's kind of like being cut at an angle. And we can see that kind of angled cut here, okay? And what we have to do then is do the surface development of it. So once again, count out how many sides you have, the back, the front and so forth. So looking at this here, we've obviously got the purple face here, the yellow face here kind of. So there, the two of them are going to be the mirror image of each other. Just folded out, they're going to obviously, one will fold to the left, one will fold to the right. We've obviously got a back surface here, a front surface, and then we obviously have a bottom. There is no top surface here because it is an open magazine holder display case. So we have actually 5 surfaces altogether. So starting off this question anyway, we're going to start off by drawing the elevation, and that is going to go on the left hand side of our page because the arrow here is pointing to the left. We can see its overall length is 50, the overall height is 86. The top of it in here comes in 18. It says it in there, 18 millimeters, you can see there. Okay, so if I just bring that up a little bit closer, and then the height of it coming up along here at the front is 52. Okay, so that'll help us guide us towards this angled portion here. So we'll start with that there now, guys. Okay. So just on that there, guys, I have a page set up here. Just turn on the light there a little bit better so you can see it. So on the left hand side of my page, you can see it there, I have set up an XY line, okay? And on that XY line, I'm going to start my elevation, X, Y, okay? So starting my elevation, I know that the measurement was 50 long, and keep it in about here, from there to there. Your XY line is where the vertical plane meets the horizontal plane, guys. We know that. We've covered that before. So 50 long, and it is 86 millimeters high. So I'm going to project up a line here, roughly 86, exactly 86 I should say. And here at this side I have another line that goes up, and on that side, just go back to my measurements here, is 52. Mark that there, 52. And then at the 86 it goes across, and it goes across 18 millimeters. So you can see here I'm marking 18 and connect them up. There we have it. That is the elevation view drawn, nice and easy. So just going to heavy that in. Nice and simple. That's just a bit of orthographic recap. Okay, so the elevation drawn there. Now, what they want us now to project was a plan view in the direction of arrow B, so looking down on top of it. So what would we see when we're looking down on top of it there in the direction of the pen, okay? So this face here, we would see it as a line. Obviously there's a back face. Essentially what we're going to see is a rectangle. We already have the length, which is 50 millimeters. So I can transfer that down and transfer this down. Okay. Usually keep a distance between your views of anywhere from 10 to 15. For today I'm going to keep 15 between my view. So starting it there, and I know the width is 30 millimeters, or I should say the depth, sorry. Okay, so with that there, and the depth 30 millimeters. Sorry there guys, the light is just playing up a little bit. There we go, so 30 millimeters. There we have it, 30 marks down. and there is my rectangle. Okay, that's what I would see when I look down on top of it. Obviously then, just heavy it in. Maybe this. Okay. So there is our elevation view drawn, our plan view drawn. Okay, that's what we'd see when we look down on top of it. And now what we have to project over is our end elevation. So, our end elevation, guys, the way I like to do it, from the corner of the elevation, project it 45 degrees, and project my width across, where it hits that 45 degree line. You can see there and there. Sorry. And then project them up. Nice and easy. And at that point there, I can now project across my heights. This is where the rectangle is at the front of it, and then the overall height of it is here. So, with that being the overall height of it, now we're going to heavy that detail in. That detail. And obviously as we look at the front of it then, it's another long rectangle going upwards, and we have this edge in here which is heavy at the front. Okay? Because when we look in technically at the front face of it there, in the direction of my pen, we see this face here, and obviously there's an edge running there at that point which we see as a line here. Okay? And the top of it is up here. Okay? There you have it, guys. That is the elevation drawn, the end elevation, and the plan view drawn. View A, view B, and view C. So I'll just label them there. A, B, and C. Now, they are known as I said, the elevation, the end elevation, and the plan. Now what we have to do is we have to do the surface development. So, rather than just starting anywhere random over here on the right hand side, okay, I'm just going to pull this a little bit to the left, I am actually going to transfer over the heights that I already have in my elevation. So, project my line across, and I'll transfer over this height, because I know I'm going to need it, and I'll transfer over the overall height. There we have it, okay? And starting in the middle, what I'm actually going to do is, I'm going to start in the middle, roughly somewhere in around here. Because if I imagine that kind of a magazine holder opening, I know there's a back surface, okay, that is the same shape as this rectangle here, okay, the overall rectangle C, not with the line. And then attached onto that is the two sides. One side here and then the other side is at the opposite side, okay? So I could actually start with that, folding down to the left. I might actually do that. So I'll start with that actually. And then I'll put in the back surface. So there we have it. That line there, I'm essentially copying this mirror image here. So the distance there was 50 millimeters. So I can take my measurements from this, or I could simply mark 50. But that distance which I've taken there now, I'm now going to mark it over. Okay, marked it there. Project that up. Okay, and then I know that distance there is 18 millimeters, so I'll mark 18. As you can see, I can simply use the set square, and then from here connect it down. So that is the left hand side. Now connected onto the left is the back surface, and the back surface has a distance of 30. So that width there, take that, and from here I can simply mark it over. Okay, another way you could do that is simply just using your set square and measure it. Okay, just showing you that you can use both. And then out on the opposite side, I need to mark over 50 again, sorry, and then 18 at the top. So 50 here, 18 up here. Project up my line, and then connect this to this. There you have it. Okay, now we have two more faces. Okay, we have the front face, okay, which we'll see is here, okay, and we also have the bottom. Now, that could actually go on in two places. You could actually connect on, I'm just thinking the front could connect on here, or it could connect on here. Just because my Y mark is there, I'm actually going to put it over at this side. So my front face, which is out another 30 millimeters, I'm going to mark that over there, and project it up. So there's my front face. Nice and easy. And the very, very last one, okay, is the bottom surface. And the bottom surface will actually look like this here. Now, he could go on technically two or three ways. He could actually attach on to this guy here, like that, a rectangle there. Attach onto the bottom of this portion, a rectangle there. or I could actually attach it on here, only this time it would be going lengthways. So it's like taking this and rotating him and popping him down in this direction. So he could go on like that, or he could actually go on here as well. Okay, because as it falls back, it will fall back into itself. The one I'm actually going to do is the one where it is going to come down like this. Okay, another one, as I said, you could do it is like that, but coming downwards. So I know it's going to come down, and the distance it actually comes down for it to match up. Okay, because if you imagine all these were to match up together, it would have to come out the same as this distance here and this distance here. So for that to match up, could rotate it around, and we would see then that's the distance down it is going to be. There I have it. And now that is the question done. I've got my 5 face in, so it's literally a case of heaving in the details. So I'll just speed up the video there. So there you have it, guys. That is the surface development of that magazine holder there, okay? Where we had the elevation, the end elevation and the plan drawn, and then we basically drew out the side face, the side, that is the back face, that's the front face, and that there is the bottom. Now, as I said with the bottom, it would have been very, very easy for me to also have done that rectangle there off one of this bottom face here, or this bottom face, obviously, and it would have been shortened version then, okay? So there is a couple of ways you could do it. As I said as well, this front face could also have been attached on over here, okay? Hope you found that helpful, guys. That is the truncated prism question completed, okay?